Welcome to another video. In this video we are going to solve binary tree level order traversal problem from the Leetcode. In this problem they will pass pointer to the root node of the tree and we need to return an array which will contain the level order traversal. So if you consider this first example where the given tree is shown in this picture, and if we see the first level there is only one node, so the first entry array will contain only 3, and in the second level we have two nodes 9 and 20, so the second array have 9 and 20. In the third level we have 15 and 7, so we have in the third array we have 15 and 7 as values. So this is the problem statement, and we need to write this function level order or BFS algorithm we can follow. So how we are going to do it is, we are going to start with a queue and we will insert first root node into the queue, and at each level we are going to process all the nodes which are present in the queue, and we are going to add the child nodes to that queue. You will understand this better once we start writing this code. So let us start writing code for this problem where we need to complete this level order function. So let us check. If root is null, then we don't have to do anything. This is one edge case we have to consider. We can directly return an empty array, and otherwise we can start implementing our BFS algorithm. Initially we are going to have a queue which is empty. I am going to declare a double-ended queue, and we are going to add root node for that queue. And now, because we are sure that at the first level we will only have root node in a binary tree, so we are adding only root to the queue, and then we can start processing this queue while len of queue. Since we have some nodes at queue, we can start processing them. We should only process the nodes which are at queue. So we will check what is the current level len. Current level length will be equal to length of the queue. And one more thing is, we have to store these values in a separate array. So current level nodes will initially be empty, and we need another variable to store all these values, this array. So initially we are going to declare level order nodes, and we are going to initialize it to an empty list. Now we will start processing nodes from the queue. So for I in range of, we can write a while loop as well, but this looks simple. Current level len, this makes sure that we are only going to process the nodes, the current nodes which are already present in the queue. So we are going to, since we are appending to the queue, we should start removing from the left. If we just use the pop, it will pop the element from the right. So here what we are going to do is, our current node will be q dot pop left. We are popping from the left because append will add nodes to the right. And after, once we remove current node from the queue, we need to process it. Here for processing we are not really doing anything. We will just add this node value to the current level nodes. Current level nodes dot append current node dot val. So now we have added value present in the current node to this list, and then we need to check if this current node has any child nodes to the left or right. If it has, then we need to add that to queue. These things will be processed in the next iteration of this for loop. Not in the next iteration of the for loop, in the next iteration of the while loop, because this will be processed in the next level. So if current node dot left, if it has a child node to the left, then we should add that left node to queue. Queue dot append current node dot left. If it has a child node to the right, then we can add that right node as well. So after doing all these things, once this for loop completes, by this time we would have added all the nodes in the current level to this array. So we have to add this array to our answer array, that is level order nodes. Level order nodes dot append current level nodes. Then in the next iteration of the while loop, another level will be processed and child node of that particular levels will be added to queue. So after finishing of this while loop, we can return level order nodes. Let us submit this solution and check whether it passes the initial test cases or not. Yes, as you can see here, this solution is passing the initial test cases. Let us discuss about time complexity. For time complexity, we will go through all the nodes once, and we are adding all those things to the queue and we are removing it from the queue. Adding elements to the queue and removing elements to the queue will be of one operation, but since we are doing n times for each node, that will be 2n times. So our time complexity is in the order of O of n. But what happens to space complexity? For space complexity, we are using, if we neglect this node for this array level order nodes, it will be O of n, because we are storing all the values which are present in the tree. If there are n nodes, we will use O of n space for this level order nodes. And what happens here? Here also we are using a current level nodes, and for this thing, and we are also using a queue. For this queue and this current level nodes, the maximum memory that we are going to use is maximum number of nodes present at a level. So that will be possible when tree is balanced. That means every node in the tree has two child nodes to the left and right. So if the height is n, if the tree consists of n nodes, and if it is a balanced tree, then height will be log n. And at log n, we can have as many, like at level 1 we have one node, and at level 2 we will be having 2 nodes, and at level 3 we will be having 4 nodes, and similarly this thing will keep on going. So our space complexity, if we consider all that, our space complexity is also in the order of O of n because of this level order nodes. Let us submit this solution and check whether it passes all the test cases. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel. Thanks for watching this video.